All right, Trig, here we are, Wednesday, May 14th. I will see you tomorrow unless an alligator got me on Disney property. That percent chance is not zero. You never know. Outliers happens, right? Stats. Here we are, hyperbolas. We're going to talk just a little bit about the hyperbola. Okay. We graphed it on a basic level last year. We have two equations for the hyperbola. With the ellipse, a squared was always bigger. All right, a squared was always associated with the major axis. X squared was always written first. It was set equal to 1. The equation was that is. This time, you have a difference, not a sum. A squared is now they have a different way of writing here. It's interesting. A squared is how we're gonna write it. A squared is written first, always. Okay. So actually, I want you to change it. All right. Put that as an a squared. All right. The center is still HK, so notice how it switched. A squared is always going to be written first. A squared is not necessarily bigger than B squared. A squared just tells you, hey, how's it going to open up? Is the graph going to open up left and right or up and down? Okay. So anyway, without further ado, this is how we're going to graph. Okay. We're not going to look at the book's examples here. We're just going to go straight to it. All right, so how to piece of paper? We're gonna graph, I think really just 2, and then we're gonna try to completing the square examples, and then that will be good. Okay, again, have out piece of paper for this, and then maybe a little exercise at the end for some points. You didn't have one yesterday, so today would be a good idea for that. Hint, hint, wink, wink. So we're gonna graph x minus 2, all of it squared over 4, minus y plus 3, all of it squared over 9 equals 1. All right, so the center, remember it's x, y, h, k. The center is 2, negative 3. The center is 2, negative 3. A squared is always first in our formula here, so a squared is equal to 4. Okay. A squared is equal to 4. So a is 2. B squared is equal to 3, or 9, so P is 3. All right, now, so what are we gonna do? We're gonna plot our center first. So over 2, down 3. Because A is 2 and it's associated with the x-axis, we're gonna move 2 to the right, 2 to the left. Because B is 3 and it's associated with the y, because it's under y squared, we're gonna go up 3, we're gonna go down 3. What we do then is, this is not an ellipse. We don't make it look elliptical. So what we do is we make a dotted rectangular box. We did this last year. We did this last year in May, most likely. Make sure it's on the y-axis. Don't make it go like that. All right. Then what we do is then we make dotted line here. We have 2 asymptotes that go through my vertices of this dotted rectangle. So if you graph this, somewhere, Desmos, if you do that there, you wouldn't see this dotted rectangle, and then you wouldn't see these asymptotes. All right, but it's giving the foundation to the graph. Then, how do the curves go? Well, you see x squared written first, so it's gonna open up with the x-axis, which is right, and then left. So again, this graph the curves need to hug the asymptotes. They need to hug the asymptotes. All right, it would be incorrect to graph it like this. You need to hug. In fact, it needs to hug better the asymptotes. All right, again, pause this wherever you need to. We're gonna try to make a 20-minute video or so. Can't run 50 minutes, all right? Then let's take a look at this next one. This time y squared is written first, and those are really the 2 graphs we're gonna have. We're gonna have y minus 3, all of it squared over 16, minus x minus 1, all of it squared over 9 is equal to 1. A squared is always written first. A squared is 16, A is 4. B squared is 9, B is 3. And the center is not 3, 1, but it's what's with x. It's 1, 3, H, K. The center is 1, 3. Okay? So I start with the center of 1, 3, 1, 3. I put a dots there. And then, you know, I can go left to right first, that's fine. So B is 3 and associated with the x-axis. So I go over 3 to the right, 3 to the left, make some dots. Then vertically I go up 4, and I go down 4 because that's A and it's associated with the Y. Then I make my dotted rectangle. And then my asymptotes go through my vertices of the rectangle. And then this graph does not open right and left. No, Y is first. Y is first. It's because Y is first. My graph always goes through kind of that midpoint right there. I'm gonna hug the asymptote better, but it's gonna open up. The curves are gonna open up and down. That's the best way of saying it. The curves are gonna open up and down. Okay. Blue curves there a little bit better. And that is a hyperbola. Those are the graphs there. All right. What we're gonna do is we're gonna write 2 equations here for your standard notes. Find the equation standard form of the equation you, sorry, I was looking at different directions here. Write the equation in standard form. So this is I think, as challenging as completing the square is gonna get. All right, so you're gonna have x squared, 9x squared minus 25y squared minus 54x minus 50y minus 169 equals 0. I'm gonna move the 169 over. So I need to put the x's together. So I need to put 9x squared minus 54x over here, and then minus 25y squared minus 50y here. Now, what I need to do in order to complete the square, I need to have a single x squared and a single positive y squared. So I'm gonna factor out the 9 that both those terms have. That's gonna leave me with x squared minus 6x. I'm gonna take half of -6, which is -3. I'm gonna square it. That's how I get 9. Well, I didn't add 9 to the left. I added 9 times 9. I added 81. I added 81. To the left, I gotta add 81 to the right. Now let's look here. I have to factor out a -25. You guys see that? I have to factor out a -25. -25 divided by -25. Now that gives me a positive y squared. And only in order to do completing the square, I need to have a positive x squared or a positive y squared. Now, crucial move here. In terms of like factoring, you'd still get a +1, but you want to factor it correctly. When I take -50y and divide it by -25, I get a +2y, a +2y. What's half of 2? 1. If I square 1, what do I get? A +1. Even if I squared a -1, I'd still get that. But again, I'd have the wrong center. I'd factor it. I'd have this in factored form incorrectly if I called it a -1. So I have a +1 here, and I didn't actually add 1. I didn't add it all to the left side. You're gonna multiply a -25 times 1. I actually subtracted 25. So I need to put a -25 on the right. I get 225 on the right in factored form. What multiplies to 9 adds to a -6. It's -3 twice, because that's half the middle term. What multiplies to 1 and adds to 2. It's only one way to get 1. It's 1. It's also a 1 and 1. It's half the middle term. All right, again, for an ellipse and a hyperbola, it's got to be set equal to 1. You can't have 225 here. We're going to divide everything by 225. 225 divided by 9 gives you 25 in the denominator. 225 divided by 25 gives you 9 in the denominator. 225 divided by 225 is 1. All right, so you would have a center. You'd have a center of 3, -1. That's a squared. It would be 5. That's b squared. B would be 3. It would open up left and right, something like that. Okay. Awesome. One more completing the square example here for us to gather a negative. That is it all right there. It's all in black. -6x squared plus 5y squared minus 24x plus 40y plus 26 is equal to 0. All right, so first off, negative 6x squared. That's now going to go over here. 5y squared plus 40y. We're going to put that all the way over to the left. Leave a space, negative 6x minus 24. Actually, didn't really need to leave a space, but negative 6x minus 24x. We got to move the negative 26 over. Got to make it negative 26 by subtracting 26 from both sides, moving the positive 26 over. All right, that's what I meant. Now, in order to do completing the square, I need to factor out the leading coefficient of 5. Factor out 5. Divide both terms by 5, leaving me with y squared plus 5y. I take half of the middle term, 8. That's 4, and I square it. I get 16. 5 times 16 is 80. If I added 80 to the left, I'm going to add 80 to the right. I need to factor out the negative 6, not because they both have it, because that leading coefficient is a negative 6. I can only do factoring by grouping if I have a positive x squared. So I divide both by negative 6. All right, that's going to give me x squared. Negative 24x divided by negative 6 is a positive 4x. What's half of 4 squared? 4. Okay. Negative 6 times a positive 4 is a negative 24. I'm going to put negative 24 on the right. Negative 26 minus 24, add that to 80, I get 30. 30 is now on the right. Okay. We'll multiply 16, adds to 8, it's 4 twice. We'll multiply to 4, adds to 4, it's 2 twice. Again, my equations for the ellipse and the hyperbola have got to be set equal to 1, so I need to divide by 30. Divide by 30. 30 divided by 5 gives me 6 as a squared. That'd be a hard one to graph. 30 divided by 6 gives me 5 for b squared. That would definitely be hard to graph. All right, but this bad boy would open up and down. Up and down with the center of it. Negative 2, negative 2, negative 4. All right, it's easy to make a mistake. All right, so before we have any sort of possible assignments, here's what I want us to look at. Let's see here, start on May 14th. This is in your SIUC pre-calc final packet, 20 points. Monday, May 19th. I think that's going to be due. All right, class wants to enclose a rectangular garden using 75 feet of fence. We're going to do this question in optimization next year in calculus using derivatives. The side of the school is used as one side of the rectangle, thus you don't need fence. Draw a picture and label the sides. All right, find a function for the area of the garden in one variable. Okay, so obviously, you can put x here if you want, but x and x, it's going to have the same width. We'll call this the length. And if the perimeter is 75 and you only want to use one variable, then you would say, well, x plus whatever is missing is 75. So to figure out whatever is missing, move those two x's over. This is 75 minus 2x. Because again, if I take x plus x and add it to 75 minus 2x, I get a perimeter of 75. Okay, so what would be the area? The area would be the length times the width. The order doesn't matter here. I can do the width times the length. Sorry, the width that's the width times the length times the width, and my area would be 75x minus 2x squared. Next year, we're going to take the derivative and set it equal to 0, and we'll have our answer right away. You don't know what a derivative is, so how in the world would I maximize the area? Believe it or not, it's not, because I'm missing one side there. It's not going to be a square. It's not going to be 25 by 25 by 25 on each side. One would think it is, but let's see. In order to maximize the area, here's what's going on, guys. This is a quadratic, and it's a negative x squared, so it's going to have a vertex up here, which is a maximum value. Okay, so if I find the vertex of negative b over 2a, that's b. The opposite of b is a negative 75 over 2 times a. That's a. I'm going to get negative 75 over negative 4, which is 18.75. 18.75. That is the x coordinate of my vertex. All right, what dimensions? So that's the x coordinate of my vertex. All right, and if I plug 18.75 into my other, so that's the x coordinate of the vertex. That's what we want. That's good. And if I plug 18.75 in here, the other, the length would be 37.5. So you've got one width that is 18.75, the other that's 18.75, and that is 37.5. And if you multiply 37.5 by 18.75 and compare that with 25 by 25, this area is actually the biggest. Interesting. Okay, we'll talk about that next year in calculus. Something we definitely want to know how to do for the early chapter. Your chapter 1 in calculus is a review chapter. All right, is to figure out the inverse. So you'll see this one a bunch. Remember, g of x or f of x is the same thing as y. So you currently have y equals 2x minus 1 over 3x plus 5. In order to find the vertex algebraically, you switch x and y. So if this was an x, it's now a y. If that's an x, it's now a y. And this y now becomes an x. You switch x and y, and then you solve for y. So you're going to cross multiply. It's going to be 3xy plus 5x is equal to 2y minus 1. Okay, and then we're going to solve for y. So you want to deal with less negative, so I'm going to move that -1 over. It's going to be positive. I'm going to have to deal with one negative. I'm going to move that over. I'm going to factor out the y they both have in common, leaving me with 2 minus 3x. I'm going to divide both sides by 2 minus 3x. Oh, now your original equation said g of x. It didn't say y, so I'm going to write g inverse of x. It's 5x plus 1. Over 2 minus 3x. I gave this question a lot to my students when I taught pre-calculus at Mount Olive. This is one we want to know how to do really well. In the fall, yes. All right, so number 11, we're going to do one in class. This is great. It's an awesome refresher for August. See, that's why we're doing this, folks. Great refresher for August. Okay, so one that would be good to explain. We're actually almost done here. Come back, do this one in class. I think we have possibly done B and C already. Let's just, because we looked at some of these examples one time. So we're going to do like this one. This one looks tough. How do I factor? How do I solve this? So anyway, I need to just give you a little help here. We're going to multiply everything by e to the x, because e to the x times 0 is still 0. And if I multiply all three of these terms by e to the x, and I'm going to have e to the 2x now. This is now just, those are going to cancel. That's just going to be minus 14. And now this is going to be e to the 5x. Okay? So I'm going to rearrange this. I'm going to have e to the 2x plus 5 e to the x minus 14 is equal to 0. And this is honestly not much different than the following. What multiplies 14 differs by 5. 7, positive 7 minus 2. Instead of x and x, you're going to have e to the x, e to the x. I do the cover-up method. E to the x plus 7 is 0. So e to the x is a negative 7. E to the x minus 2 is 0. So e to the x is equal to 2. What do? I attach natural log to both sides. This is not going to be an answer. You can't have natural log negative 7. Nope. That is very much an answer. X is natural log 2. X is natural log 2. Okay. This next one here, I'm going to divide both sides by 12. I'm going to have natural log of 5x plus 1 is equal to a third. What do? I attach e as a base. E as a base. Okay. Then I have 5x plus 1 is equal to e to the 1/3, or the cubed root of e. I'm going to subtract 1 and divide by 5. I'm going to subtract 1 and divide by 5 to get my answer. All right. And then lastly for us today, let's go back to college algebra, chapter 1. How do I solve this? I subtract 3, divide by 2, I have this. Remember, you can live 3 miles or blocks from the tracks to the right or to the left. 2 answers there. The absolute value of 3 is 3, and the absolute value of -3 is also 3. So I set 1/3 x minus 4 equal to 3. I get 21. Set 1/3 x minus 4 equal to -3. I get 3. Okay, folks, man, we're at 20 minutes, so here's what I want you to do. Here is what I want you to do, because I do want you to turn in something to make sure we are watching this. All right, so on a separate sheet of paper, I have 3 questions for you. Number 1, juniors, give me 3 ideas of majors or jobs you want to do right after high school. I think the vast majority of us are going to attempt college there. So what are 3 ideas of majors right now? Okay, number 3, what are you interested in? I would like to know, all right, summer. What are a few things you're excited about summer? Are they trips? Are they races you're gonna run? And then also, what are you doing for employment this summer? All right, and then lastly, number 3, what is a big question you have for stats and or calc next year? Is there anything you're worried about? Again, I have big goals of having you accomplish the most in content. All right, calculus is for someone that really wants to take calculus. All right. I think a lot of people, if you're motivated, you can do stats. Anyway, so let me know that as well. All right, and then, so again, all on a separate sheet of paper. We're gonna do 5, because I'm gonna give you 5 points for paying attention. Okay, here's number 4. Cosine 2x is equal to 1/2. Can you solve that? Or cosine 2 theta is equal to 1/2. Where on the unit circle is cosine 1/2? All right, so you're gonna say 2 theta is pi whatever, 2 theta is pi whatever. You're gonna divide by 2. Solve that for me. All right, you can pause this, run out of space here. So believe it or not, you, again, because you can have natural log of anything between 0 and 1, and that'll give you a negative. So solve this. It's not no solution. All right, it's not no solution, because I can attach e as a base. I'm gonna have x minus 2 is equal to e to the -2nd, which is an okay answer. I'm gonna have 2 plus e to the -2nd, which is a fine answer, and a great answer here is the following. All right, anyway, folks, that video is long enough. Thank you. I know you don't have a bad note. I will talk to you tomorrow on Thursday. This is Yak Math Videos, signing out.